Hi everyone. So we're going to sort of apply our knowledge of the exponent laws into the laws of logarithms. And like exponents, there are three logarithms laws. Now hopefully this video goes better than the first 15 seconds of it anyway. All right, let's start with the product law of logarithms. We can say that log c m times n is going to be log base c of m plus log c n. So the logarithm of a product of numbers is the sum of the logarithm of numbers. Now remember, logs, we're really dealing with exponents, so that when we multiply two quantities together, well, what happens to their exponents? Provided they have the same base, we just add the exponents. And that's what we see here in a weird way, right? Like, this is changing really quickly on us. But quotient. So, for instance, if I have m divided by n, and they both have the same base and they have different exponents, well, what do? Well, we simply subtract the exponents. And that's what this is saying here. So log base c of m divided by n is going to be log base c m minus log c n. So the logarithm of a quotient of numbers is the difference of the logarithm of the dividend and the divisor, respectively. Right? Basically, the exponent of the numerator has to go first, and the exponent of the denominator has to be the second number being subtracted. Now, the power law of logarithms just simply says log base c of m to the power of p is going to be equal to p times log c m. The logarithm of a power of a number is the exponent times the logarithm. So really, a power to a power, an exponent to exponent, well, what did we do with those exponents? Well, we simply multiplied them together. And that's what we're doing here. So I'm going to talk about proofs. I'm just going to talk about them. Here's a proof. And I've written up this proof, and I think it's good. I think it's strong. I love proofs. Now, proofs are an increasingly important element of higher level math. You should get used to reading proofs. In your first year university, you will be asked to demonstrate a proof. And which proof? I don't know. There's going to be many proofs. So what are proofs? In math, we don't make mathematical statements unless they can be proven. And these small steps of proofs, accumulated over thousands of years, gives us our whole mathematics field. And like I've said, mathematics is a weird field because we don't make a statement unless somebody has shown it to be true. Now, from time to time, I might make a mistake, but all my reasoning is based off of these proofs. So if you're going to study math at a higher level, get used to proofs. And by the way, a proof is the poetry of math. They are really, really spectacular. They take a while to get used to, but once you're used to them, you really like them. So I'm going to prove that log base c of the product law of logarithms. Log base c of m times n is going to be log c m times log c n. So I start off with some definition here, and then I'm going to write it in exponential form. Now notice what I am doing. Try to follow along. Spend some time with it. Now, this second one, I made a mistake. A very simple mistake. I'm going to prove the quotient law of logarithms. So please erase this part and write log base c of m divided by n. And that's going to be log base c m minus log base c n. And I go along, I start off with a definition, start off with assumption, and I build my mathematical argument this way. Try to follow it. Again, the proof of power of logarithms. Start off with a statement that I'm supposed to prove. Start off with some definitions. And I go. Try to follow what I'm doing. It's really concise. All right. Enough with proofs. Let's get on to some examples. Now, here, what I notice